Good evening, everyone, and a very warm welcome for the AMDOCS Talent Magnet webinar. Today's webinar is on network slicing, a key enabler for 5G. Before we start today's session, a quick note. Right now, we have all of you on mute. So, should you have any questions during the session, please feel free to type it in the Q&A tab in the Zoom control panel, and we will be taking these questions towards the end of the webinar. So we will have dedicated 10 to 15 minutes towards the end of the webinar where we'll try to answer all your queries. And in case there are any questions that remain unanswered, we will provide you the mailbox address. You can write to us and we'll reply back to you. So a brief intro about our speaker today, that's Nidhi Sharma. Nidhi is an experienced Q&A professional with 13 years of hands-on cutting-edge experience in the IT industry. She is currently associated with AMDOCS for over 12 years. Nidhi is a double master's in MCA and MBA. She has attained international certification for certified in Scrum Master. So Nidhi, over to you.
Yeah. Hi. Thank you, Neha, and hello, everyone. Um, so today I'm here to present my views on network slicing and how it is a key enabler to boost 5G technology. So what is in store for today? These will be the topic I'll be covering today, including starting with the definition of 5G, the evaluation and comparison between 4G, 5G, brief description of key building blocks like VNF, NFV, SDN, PNF, CNFs, and about the ONEP. And last but not the least, how AMDOCS is leading the charge for providing 5G solutions through its open 5G AMDOCS Solutions Suite and AMDOCS 5G Slice Manager, which is industry's first 5G ready charging system. And AMDOCS is the first company which is successfully providing the event collection challenge with its new 5G Slice Manager that I'll be covering in my later slides. Okay, so as um, all the webinars start with the definition of what we are going to present. So here we have a definition of 5G. So the standard definition of 5G is what we know is a fifth generation wireless technology, and it is just not the upgradation of 4G. Rather, 5G is a new technology with so much power and dynamism. And it is the latest iteration of cellular technology equipped with three main features: massive speed, lower latency, sliceability. So what do we understand with these terms and technologies? I'll be explaining later. And it is also ability of connect more than 2 million devices per square kilometers simultaneously. So this is a standard definition of 5G, which you will get everywhere. And so next is like 5G technologies, what advanced features 5G technologies is providing. So on high level generic terms, it is a architecture. The 5G architecture is device centric, distributed, programmable, and cloud based. So when we talk about these terms, what does these terms mean when we say device centric? So device centric is actually a paradigm shift in the design of future cellular technologies. In current days, like whenever one mobile is connected to other, it is going through network uh, network station and then connecting to the other mobile. But in 5G is it is like uh, device to device connectivity is there. So mobile will be connecting to the other mobile directly rather than going to any network antenna. So this is the generic mean of device centric. It is distributed. Distributed means you are giving more power to edge devices. Edge devices like our mobile devices, IoT devices, and the devices which are working on the network application at the edge of the network application, like self-driving car, vehicles, high frequency trading or mobile application, video programming, video games, etc. It's programmable. That means the hardware can be softwareized. They can be moved from hardware to software. And cloud based, this entire technology is on top of cloud architecture. Next is high data rates. We are getting bandwidth up to 10 Gbps in 5G, 1 to 10 Gbps connection to end to end points. That means we are not losing the throughput of the devices, and the connectivity is intact in during entire connection. Um, 1 millisecond end to end round trip delay. This is what we are providing, the low latency. What is low latency? Like the connection between the device to device, or a connection between establishing the network is 1 millisecond. In 4G, it was earlier, it was 50 milliseconds. So it is reducing the latency, and we'll be getting a low battery consumption because the latency is low. That is automatically will improve the battery life of your systems. We have large numbers of supporting devices, better connectivity we will be getting, and lower cost of infrastructure development, not in initial phase but on later phase it will be there. So next is I just prepared a picture of how evolution started from 1G to 5G. So if we see, we started with 1G. It was all started with 1G, where we were only able to make the phone calls. Then it gradually upgraded to 2G, and in second generation, apart from voice call, the text messaging system was also introduced, and 2G networks were digitalized. In third G, 3G, third generation, it allows. There was a huge difference between 2G and 3G because we get more services in 3G. We were the picture sharing, video sharing, Bluetooth connectivity was introduced in 3G, and going from 3G to 4G, it was a upgradation of the all the services which we were getting in the 3G. So fourth generation offered the first true internet broadband data transmission rates, higher rates of data transmission. It was 10 times faster as compared to 3G. And now we are moving very fast to 5G. But if you see that 5G is not simply the upgradation of 4G to 5G. It is entire a different all over technology, which is beyond the telecommunication services. It is touching all the other services like hospitality, banking, mobility, hospital services, industries. So 5G itself is overall entire technology shift from 4G to 5G. So this is a high level overview that how we moved from 1G to 5G. So if we compare what is um, difference between 4G and 5G technologies, so here are few points which we can compare, that what was there in 4G and what is now changed to 5G technologies. So and this you will get everywhere. You'll be getting all these points, like 4G is fourth generation technology and 5G is fifth generation technology as per their name. Data bandwidth were in 4G was up to 2 Mbps to 2 Mbps to 1 Gbps, which is now in 5G is from 1 Gbps and higher as per the need, up to 10 Gbps. The latency of 4G technology is about 50 milliseconds, which is now enhanced up to 1 millisecond. 4G offered CDMA. 4G was running on the CDMA services, and 5G is running on OFDM and BDMA services. So, what we understand with OFDM and BDMA services, which 5G is offering, is like if we talk about OFDM, it is a kind of digital transmission of the existing technology which was there already, and encoding it to digital data for the multiple carrier frequencies. And BDMA uh, is the we can understand that the base station which is now creating a beam connectivity with the mobile and mobile stations rather than spreading their frequencies. So it is end-to-end point connectivity from the base station to the endpoint devices. Next is that 4G cannot differentiate between fixed and mobile devices, and 5G has a capability to differentiate between fixed and mobile devices because it uses cognitive radio techniques to identify each device and offer the most appropriate delivery channels. So, cognitive radio technology means the technology which is based on the surrounding radio environment, which helps to identify differentiate between the fixed and mobile devices. And then 4G has the advantages of high speed handoff global mobility, and 5G has advantage of extremely high speed and low latency. 4G can be used for high speed application, mobile TV, wearable devices, and 5G can be used for high resolution video streaming, remote control of vehicles, robots, and medical procedures, and many more things. So this is a few points which we can differentiate between what was there in 4G technologies and what is there and about to come for 5G technologies. So now coming to the main key building blocks of 5G. Um, we have VNF, NFV, SDN, and apart from that, we have PNFs and CNFs as well. So VNF is actually the softwareization of the hardware systems like switches, routers, servers. They are being virtualized, like moving from hardware. We are virtualizing them from hardware to software. SDN is where the network is being softwareized. So software defined network, when the network is being softwareized, virtualized, it is SDN. And in SDN, the basic fundamental is that the data planes and control planes are decoupled, and the control plane is fully programmable. And NFV is the network function virtualization, when the our virtualized functions are running on top of the cloud. That is NFV. Apart from that, we have PNFs also and CNF also. PNF is physical network function, which can be virtualized, but it depends as per the need, whether it is really needed to be virtualized or that has to be still like a hardware, other physical element in the network. So we can, for an example, we can see that let's say if there is any hardware for firewall, and it is giving a very high performance, and the customer don't want, the service provider don't want to get it virtualized, and don't want to invest again to get it virtualized, because already the performance of that firewall is very good. So in that case, the PNF is being used, as there is no need to make it virtualized. And CNF is containerized network function. When the functions are being containerized, they are called CNFs. Um, then we have ONEP. So ONEP, we can understand that 5G and ONEP are together a two critical piece of same puzzle. ONEP is having an end-to-end network slicing capability, and it is a game changer for 5G. And um, it is giving an end-to-end network management system, as per the HC guidelines, and it is very crucial, because to enable the 5G, it is automating all the systems to enable 5G. And it is having a distributed and virtualized architecture, and AMDOCS is leading the slice modeling work in ONEP, ONEP platform. And AMDOCS is also a co-founder member of ONEP along with AT&T and T and Linux. And it is and AMDOCS is also um, sorry. Yeah, AMDOCS is contributing, continuously contributing millions of code for ONEP enhancement. Okay, so now my next slide is on network slicing, the concept. So, what is network slicing? So, in generic term, high level, if we go with by the definition, I'll read it out. So, what is network slicing? Network slicing is defined as a logical or virtual network customized to serve a defined business purpose or customer, consisting of an end-to-end composition of all the varied network resources required to satisfy the specific performance and economic needs of that particular service class or customer application. Definition wise, it's a very, very big sentence. Okay, so if you try to understand what is network slice, actually it's a method of creating multiple unique logical and virtualized network over a common multi-domain infrastructure. So using SDN and NFA orchestration, NFA orchestration and analytics, mobile service providers or mobile operators can quickly create a network slice. And network slice is specific, if there are different services which user want to use, so for every service, every different service, a separate network slice can be created to serve the purpose of the particular slice. um, let me talk about the use cases of network slices, so that will be easier to understand. We have majorly, we have three major categories in which of the use cases for which the network slices is being designed. So first is enhanced mobile broadband, also called as EMBB. This is like a separate slice is created for EMBB, which is basically supporting the video centric applications like video streaming, virtual reality, which consumes huge bandwidths. and required a very high data rate. So slices are the slices which are providing services for where the high data rates and high bandwidth is needed. Second use case is ultra reliable low latency communication, which is also termed as URLLC. So it is a set of this slice actually um, is useful where really low latency is needed. A few few examples can be um, intelligence transport system, banking domain, surgery areas, where the rate is not expected to be very high, but yes, the latency is expected to be very low. Um, let's take an example of any financial transaction. Let's say someone goes for a shopping and they swipe a card, and this communication, when you swipe a card, this communication is going to the banking domain, and from there you are getting a response and your transaction is being approved. So during when you do the transaction, a communication is open between the device and the swiping device and the banking, and it's a kind of a door open where security threat is always there. So you don't want that door open to be for 5 to 10 minutes, or the time when an intruder get a time to breach the security features. So this is a scenario where you want that as soon as you do the transaction, it should approve without taking time, so that the security threats should be minimal. So this is where a low latency service is being used is needed. So similar way, it is being used for transport system also. Like a human brain takes up to 50 to 70 milliseconds to see analyze. Let's say two cars are running in parallel and there is a chances of collision, and human breaks takes time to analyze the situation and put a brake on your vehicle to avoid the collision. And having a low latency in 5G, this uh, um, timing is decreased up to 1 millisecond. So in a span of time, the automatic vehicles will analyze that there is other car is coming and there is a chances of collision much ahead as the human brain works. So the chances of collision is minimal. This is the way the low latency can be used. So this low latency services is being provided by the URLLC slices. The third type of slice is massive machine type communication, which is MMTC. This is where the devices, this is going to connect lots of devices which will be using part of IoT, Internet of Services, like millions of devices with for the sensing, metering, and monitoring, which will be connected to the network, where we really don't need very high data rates or very low latency. And so, just going to the basic facts also. So, it is a term like journey from one side fits all approach to selling customized services with certain characteristics and quality guaranteed. So earlier till 4G it was like whatever service you want to use, you need to select whatever is available, but now it is moving to whatever you want to use, you can select that specific service rather than using everything, taking everything, purchasing everything. End-to-end slicing is a key feature proposition for customized enterprise network. and it is fully automated end-to-end slice guarantee service quality. And ONEP provides the open source platform for end-to-end orchestration. And the business of network slicing is expected to be $1.9 trillion economy. 5G economy is much, much more than this. And network slicing is expected to $1.9 trillion economy. So, okay. So moving to the next slide is now the architecture of network slicing. So as you see from the picture, we have major three layers and one management layer in the architecture of network slicing. So basic diagram is this, wherein the lower layer is resource layer. It consists of all the it consists of all the network functions, VNF, PNF, networks, system storage. So whatever both the resources and network functions are there, it is placed in resource layer. The next layer is network slice instance layer. Um, this is the middle layer, which actually consists of slices where we provide the network capabilities uh, to create the slices, and slices can directly run over this network instance layer. And also one slice can one network instance layer can serve one or multiple service instances. When we say service instances, they are the network slices. And one more thing is to take in note that if on one service instance layer, if two different type, one or more different type of slices are being run, they do not share resources. Even though they are running on the same instance layer, they don't share the resources. That is the good thing, which is separating the one slice from other slice. The third layer is service instance layer, which is the upper layer of the architecture. And this is where the slices are being consumed and the services are offered to the customers. We have the management layer also, where for every every layer, resource layer, network slice layers, or service layers, we have a management function. So for the first layer, we have a resource management function, which is related all the underlying resources and network function. And for networks instance layer, we have a network slice management function, which actually is a slice manager, which manages all the life cycle of the slice and the interaction with the management function. Many a time it happens that one slice is a combination of various different sub slices. So for every sub slice, um, there will be a different unique management function. And the last one is a communication service management function, which actually interacts with the slice manager and interacts with the services. Okay, so now moving to the next is the life cycle of a network slice. So this is also a very important part to understand. Um, as you see that there are four phases of a network slice life cycle: preparation, creation, runtime, and decommission. Preparation phase is where request has been raised using the predefined templates or as per the specific needs by the customer using the OSS PSS platform. And the requirement of the slide is being discussed in this phase. Whatever is needed, the design creation and modification part is being taken care during the preparation phase. um, the next phase is instantiation, configuration, and activation, where the slice is being prepared as per the specification which has been um, raised by the slice templates. So we have a different steps for this phase. We have many steps. Like once the slice has been requested, it is first checked into the inventory. If we have already predefined slices available over there, if yes, then it goes for the activation process. If not, then it requested then it a request has been will be sent to the request subnetworks, which will instantiate the NFVO and SDN orchestrator to create a subnet work map. And then the request has been the resource request is being asked, raised, and VIM. Um, then VIM interface that will create the VNFs for the new network service. And then the resource is being allocated to those VNFs and instantiation completed for that particular slice request. And then once the slice is ready, then it is notified that slice is ready to use, and it is and it is ready to be configured and ready to collect the events. So when the slice is ready, when it is in the actual runtime, then the supervision and reporting is taking place in the runtime phase. And here during the runtime, only the usage report as per the performance, as per the deployment of the slice is generated. And the last phase is decommissioning. So once the slide is has completed its SLA or the timing for which the slice was requested, then the slice is decommissioned. VNF is again sent back to the the inventory, and that slice does not exist anymore after this phase. So this is the entire life cycle of the network slice. So my next few slides is basically on the AMDOCS way, that how AMDOCS is working specifically towards the 5G and network slicing area. So the next slide is benefits of network slicing as per AMDOCS way. So how AMDOCS is providing their 5G services. The AMDOCS 5G services are fast to deploy, open to drive innovation, smart, efficient, um, to orchestrate and dynamic networks, and quick to capture every revenue opportunities during a runtime only. It is achievable by AMDOCS because AMDOCS is utilizing the latest NFV technologies, which is running on top of the ONEP automated platform and logical network architecture. AMDOCS is coupled its PSS and OSS functions along with the NFV slicing management functions, and is providing a single offering where we include the ordering and charging per slice into the overall slicing management offering. And the AMDOCS is following the HC NFV definition to orchestrate, and which is based on the all the three GPP specifications, and hence it is using the on a platform to automate end-to-end slice management. So in ONAP, there is a network slice use session management, which is HCZSM, which is addressing that how to automate end-to-end slice management. And AMDOS is leading the slice modeling work in case track of from the last three releases. And based on that, it is providing the significant uh, business enabler, becoming a significant business enabler by providing the revenue opportunities to the operators. It is capable of enhancing customer experience because it is providing the zero touch automated platform for end to end slice life management. It is efficient and simplified operations and realizing the cost efficiency because it again the zero touch policy and due to the automated platform and the automation automated processes are running on based on the AI artificial intelligence policies and my next slide is based on the 5G leadership and how AMDOCS is leading the charge globally in 5G implementation. So if you see this slide, I have these are the different key building blocks for network slicing in 5G mm, um, for 5G. So AMDOCS is involved from the first step itself. So if from the first step itself, like AMDOCS has a very robust understanding of network and service transformation. And through AMDOCS OSS NFV portfolio, it is helping service provider to deploy and configure NFV services and platforms and using the hybrid network and services. And hybrid network, cloud networks, it has a collaboration with the Microsoft, Azure, etc. And the next important building block, as I explained in my previous slide also, so AMDOCS is having their own SD-WAN product, which is an extension of SDN, and SD-WAN applies SDN to networking connection that covers a wide geographical area. And in future, AMDOCS is planning to um, provide SD-WAN as a service also. The third and most important building block is ONAP. So here, AMDOCS is a co-creator of ecom code along with AT&T, and it is rated top three vendors who contributed the code to ONAP. And AMDOS has contributed millions of codes for ONAP till date. ONAP is actually enabling existing and future networking use cases and provides a comprehensive solution to enable network slicing as a key capability of 5G. And the last one is network slicing. So here AMDOCS has introduced industry's first 5G ready charging system and is the first company also to successfully negotiate um, for event collection challenges. And it has a new AMDOCS 5G slice manager solution, which is again a game changer, which is providing a runtime ordering and billing reports to service providers. So we can see that AMDOCS is involved in this 5G journey from the first step itself. AMDOCS is providing their 5G solution suite, which is open AMDOCS Open 5G, and this I will quickly go through this slide that AMDOCS Open 5G solution suite is designed to help service provider accelerate their 5G journey to move the digital society of today to new era of virtualized and distributed cloud networks, hyperscale IoT, and intelligent connectivity, which is the base of the 5G. And AMDOC's Open 5G solution is powered by Linux Foundation's Open Network Automation Platform, and it is using HC-defined Tosca bit templates to create the slices, and it is representing VNF and PNFs across the different notebook domain. And Open 5G is part of AMDOC's open network portfolio, which gives service provider the freedom to work with a wide range innovation partners and across multiple um, environment and domains. Um, Continuing on this slide, what is there in Open AMDOC's Open 5G? So we have three services: Open 5G Fast, Open 5G Smart, and Open 5G Monetize as part of this solution suite. Open 5G Fast is actually providing the automated suite for end-to-end rollout and deployment solution. It is running on top of strong 4G foundation, where node of 5G NR is connected to a 4G network till you become 5G standalone technology. And a massive MIMO is introduced to utilize the better existing bandwidth. Open 5G Smart it supports transition into cloud-based 5G network and provides a gradual and managed process towards fully autonomous operations. And it is all about to enhancing network automation and intelligence and reduce the cost and improving the customer experience. Open 5G monetize. Based on 3GPP compliance, charging platform is being designed by AMDOCS to run up to the scale of speed of 5G. So the other is essential elements of AMDOC's monetized platform. It is including rapid partner onboarding, agile catalog to create the right offers for tomorrow, and digital user engagement. Some of the examples of 5G monetize use cases examples can be a slice-based connectivity, pay-as-you-grow network infrastructure, 5G on the edge devices, value-added services, embedded communication, ubiquitous connectivity. So this was a brief description of Open AMDOC's Open 5G solution suite. Next, we have a newly introduced AMDOCS 5G Slice Manager. So AMDOCS end-to-end network slice lifecycle management and monetization solution integrated with ordering and charging, which helps service provider achieve operational efficiencies and optimize return on investment as well as cutting time to market and reducing the cost and risk of innovation. Um, AMDOCS led survey with the 50 mobile operators across the globe, and the result was that 52% service providers believe that network slice as a service will be leading approach to network slice monetization. So from this survey, the idea of getting a 5G slice manager monetized report came into the picture, where 30% expected that quality of service parameter is 5. So AMDOCS 5G slice manager enable the automation of logical network segmentation with slice customization, logical network isolation, and quality of service control in real time. And AMDOCS 5G slice manager is industry's first 5G ready charging and billing system, which I mentioned in my um, index slide also. And AMDOCS is the first company with successfully negotiating this event collection challenge with its new AMDOCS 5G slice manager solution. And this solution maintains track of resource consumption on every network slice and servers as a charging triggering function. And this passes information about slice operation as well as resource consumption, utilization, and performance to the charging function. And it is totally based on recent 3GPP release 17 guidelines. As you see, I have mentioned that it has three parts: slice design, slice automation and orchestration, and slice operation. This is the simple, the similar slice life cycle management, which I explained in detail in my previous slide. So, slice design actually enable the service of slice creation, automation, testing and debugging, packaging and distribution of a slide. So this is having a facility of reusing the building blocks from the existing network slice also. Wherever we have already existing slide, we will use that. Or if there is any specific slice is requested, then it will create a new slice. The second part is slice automation and orchestration. It actually initiates the necessary VNS, PNF, CNS, and network resources and connection end to end across the network domain. And this module follows 3GPP technical specification guideline for management and networking, the slice. The third is the slice operation. This monitor and assure the behavior and performance of the various slices through collecting network function and infrastructure data, analyzing the performance data and events, and triggering the appropriate action of resource scaling, elasticity, and automatic healing to meet slice requirements. Um, the solution is actually active hybrid inventory module and vendor agnostic. It is having a continuous monitoring and performance analysis facility for both physical and virtualized network slice components. And based on the massive data collection, static modeling techniques, and AI ML analysis, uh, AMDOCS 5G slice management system carries out performance prediction and provides early warning of any degradation of slice or performance in SLA. So this is the main very good feature the provided by AMDOCS 5G Slice Manager. So from this slide, I will end this session. And for more details on NFV, SDN, VNFs, and on it, you can refer my LinkedIn profile, and I have given a webinar in past also on specific to NFVSDN and second on ONEP. So you can refer my LinkedIn profile. You will get the links over there, and there are articles also and blogs also present on my LinkedIn profile. For more details, you can go through that, because I majorly focus in this presentation. I majorly focused on 5G and network slicing area. So
So, Nidhi, would you like to take a few questions? We have a lot of questions in the Q&A section. Maybe you can pick few questions from there.
yeah, sure, Neha. I will check the questions. So, okay, I need to check question and answer tab. Sorry, I was checking the chat window actually for the questions. Okay, so I see there is one very interesting question, and approximately this question is being raised many a times, that what is the expected health hazards for 5G technology? From the beginning of the discussion, when the 5G was being discussed, this question is always there. But I will like to say that this question is not started from the 5G, but this question is there from the 3G itself. What will be the health hazard for 3G? And then the same was with 4G also, and now it is very, very hot topic with 5G as well. Um, Um, Actually, if we go over the WHO guidelines, um, the frequency from 0 to 300 um, gigahertz is not, actually, it's not hurting anyone, um, because the cell radius decreases the power density, and it will reduce compared to existing network. So there is not much, there is no health hazard if the 5G is being implemented, because that is already taking care of the range which is being really going to impact the health is not been approved to go up to that range. um, The question is, there's one question that the use cases in 5G and network slicing the same. Yes, the basically, as I already explained in my previous slides, that yeah, basically it is based on the three use cases. Um EMBB, URLLC, and MMTC, where one is representing where the need is of high broadband, high rate of data rates. The second is where the low latency is being needed, like intelligent transport system or banking domain or remote surgery areas. And the third one is MMTC, where millions of devices will be connecting um, through IoT. Millions of IoT devices will be connecting to each other. So the use cases is almost same, and we have a generic slices, predefined slices for all these cases. Most of the time, these predefined slices can be used, and if there is very specific requirements, then a new slice using the sub slices can be created. One question is, what is the future scope after 5G? So scope is never ever ending. So after 5G, there will be 6G, 7G with different um, requirements, whatever um, is needed or whatever is upcoming. So the the scope of enhancement or scope of upgradation is always there. So definitely there will be future scope after 5G. There's a question: are the VNFs running on top of PNF? Yes, VNFs are running on top of PNF. VNFs are the virtual network functions which are running on top of physical servers and physical networks. Um, um, there's one question on ONAP, which I think from AMDOC's perspective, I have to take it. I have already explained that how AMDOCS is involved in ONAP. So uh, I, I already explained that how AMDOCS is the top players of ONIP implementation. Um, ONIP actually provides a modular architecture and a common environment for number of operational process, as well as it is providing end-to-end service life cycle management. When I say service life cycle management, it is network slice life cycle management across the multiple network and technologies. um, and AMDOCS Slice Manager, AMDOCS 5G products are all based on running on top of ONEP platform. AMDOCS is a co-founder, co-creator of ONEP along with AT&T and Linux Foundation. And I will suggest to go through my LinkedIn profile and get this ONEP. There is one ONF webinar link is there, so you can refer for more detailed architecture and how it works from that slide, from that presentation actually. Um, there are so many questions still, and we are running out of time, so I will not be able to take all the questions right now. But you can share your questions or queries to talentmagnetindia@amdocs.com mail ID. It is mentioned here, and we will try to respond on your questions through the mails. And with this, I would like to thank you to the wonderful audience who participated to for this webinar, who joined this webinar. Thank you. Neha, it's up to you now.
Yeah, thank you, Nidhi. Thank you everyone for joining today's webinar. So please keep a tab of your mailboxes. We'll be sharing all our upcoming webinar details to your email IDs. Thank you so much. Have a nice evening. Stay safe.